So while designing these characters, I start out with a paint program. This is MT Paint, which is M, letter T, paint. It's free, extremely powerful, and lots of effects, lots of stuff you can do with it. Really useful. So this is a test of zooming the character using the hardware sprite zooming feature, which, believe it or not, the Atari has. The Atari system has two levels of, and it's not zooming, it's just doubling or quadrupling the pixels of the player graphic. So I call it a sprite, but they call it, whatever, player 0 or player 1. So this would be a punch, and what I'm testing is whether I should zoom the character or whether I should do two separate sprites. And with two separate sprites, then it will be a higher resolution punch or kick or whatever, higher resolution attack. But with zooming, then it will be lower resolution, but it will have more color overall. So, this is one option here, with the punch, the knees out, and everything. You can see all the details, but and I'm going to go ahead and save it the way it is. Now, the way it would be this. So that's your 8 pixel wide. Now, once it's doubled using the hardware, then it will be 16 pixels wide. You can also quadruple your sprite, and it makes a giant, really super blocky image, but that's useful. You can use it for things. I used it in Titan Axe for all of the enemies in the game. When I first started programming Titan Axe, I was very ambitious, of course, and I made a lot of bad guys, and I made a lot of good guys too. I wanted there to be 3 good guys and to pick from, and lots and lots of bad guys. And I was just drinking the Kool-Aid. I was using all of the different options, the kernel options. I was using player colors. I was using background colors and stuff, and just as much as I possibly could. But now the way the kernels work, they generate limitations. So basically, the Atari's meant to start out with a single color background and single colored sprites, and then you can use a ball or a missile for each of them. The ball is part of the background, the missiles are part of the characters, and so they adopt the colors of each character. Now, whenever you add an option, it takes away something. Okay, so for instance, if you add, suppose you add player colors, player 0 colors, well then you'll lose like your player 1 or player 0 missile, so you won't have that to use. If you use both player colors, you'll lose other things. Now, one of the things that you really want, something I really wanted for backgrounds, was to use no blank lines. Now, no blank lines will make it so that you don't have any lines in between each of your rows of color, and it makes it so you can design better looking backgrounds. Now, for someone making a Pong game, or making their own Centipede, or making their own tank combat game, or for the majority of classic Atari representations, you're not going to mind too much if there are lines on your screen or at all. It might not bother you. But if you're doing pictures, if you're doing a background image that's meant to represent something, then you're probably not going to want lines for everything. Now, to get rows of sprite colors for my enemies and for my good guys in Titan Axe, I had to use the player 0 and player 1 colors, meaning I could not use the no blank lines option. Now, if I used the no blank lines option, then player 0, I think player 0 could have colors, but player 1 couldn't, something like that. So Now I have this newer way of generating sprites. I don't need player 0 or player 1 colors. And so I can use no blank lines in every instance, in every instance where I'm using that type of sprite design. And that helps a lot because you can have more intricate, colorful, and you know, slightly more realistic backgrounds. So with this idea of zooming the character, the other idea would be to generate 2 sprite instances, because you know, when your character punches or kicks, I'm sure you know this if you played Street Fighter 2 in any incarnation or any fighting game, the character is now wider. You're dealing with a wider sprite. So now with any game system other than the Atari, that's just, you know, to be accepted. It's that's how it's going to have to be. So you suppose you have a 16 pixel wide sprite in a more modern, like maybe a Sega, Super Nintendo, or Nintendo game. You're like, okay, I've got a 16 pixel wide sprite. Well, now I'm punching. Now my character is 24 pixels wide. And so in the little tiles that you're using to make your character, you're just going to add a new row of tiles to the character for the extra length, where the punch extends the arm, or the leg or the kick extends the leg, etc. With the case of the Atari, you're only dealing with 8 pixel wide sprites. And one of the unique things about the Atari that's actually really, really cool is that your sprites can be as tall as you want. They can be as long up and down along the y-axis as you want. You can make the sprite take up the entire screen if you want to, but they can only be 8 pixels wide. So unless you're using methods to double them up, or if you're using hardware to double them up. In this case, if I use hardware to double them up, here's my thinner 8 pixel wide character. This would look like a pretty poor representation of a punch because he's only reaching out a little tiny bit. And I'm not saying I couldn't do that. You know, that could still work to have an 8 pixel wide character attack, but you'd have to be really, really close to the other character. Maybe have the character move forward suddenly to add some extra potency to the attack. But what you really want is a wider sprite. So to do that, use hardware. And when you use hardware, it doubles or quadruples your pixels. And so you're going to end up with a lower resolution character, but longer reach. Okay, so now if I go ahead and redo, here's what we'll end up with. And now, if you want to see how big this sprite is in the modern world, okay, I'll just go ahead and I'll zoom him to 100%. That's how big the character is in our modern high-resolution world. You can't see him. I mean, he's tiny, tiny on the screen. So I am zooming these drawings 2,000% to make them be in the screen enough to even see what I'm doing. And I'm making sure that I'm dealing with 8 pixels, and then if I'm zooming, then I'm using scaling so that I know that that is an exact representation of what I'm going to achieve using hardware scaling, which, you know, is just pixel doubling on the Atari 2600. So that's a neat feature that the 2600 can pixel double or pixel quadruple for your characters. You're given an 8 pixel wide, 16 pixel wide, or 32 pixel wide sprite, and that's hardware. It doesn't slow down anything. It doesn't take up any more space because your representation is still only 8 pixels wide. Now, of course, how tall your sprite is comes into play. You know, the system is meant to deal with 8 by 8, and so when you are doing an 8 by 16, that's going to double the amount of ROM space that graphic takes up. These characters are on average between 35 and 40 pixels tall, and as you can see, there's some space above his head, and that may or may not be removable. And of course, if you're exceeding a threshold that is a multiplying, that is a multiple of 8, you're going up into that next bracket of ROM space that it's taking up. So it might take 32 bytes of ROM space. It might take 16, it might take 8. It's a row, and it's very simple. It's a row of bits off and on. And then you're giving it has a single color. And so that brings me to my way of designing graphics. And this is kind of a tutorial, I guess, for someone that, you know, might want to be able to do this in their own game. And I really don't want to just give away everything that I do, but this is essentially, you know, a discovery. And I've made a couple of discoveries that are going to help in making games with lots of sprites and with lots of color that look better than normal Atari games. This first discovery, okay, is that, and this is unique to the Atari 2600. I don't know how many other systems might actually do this. I don't think even the home computer, the Atari home computers, do this. Okay, it might be that the 2600 is the only system that does this. But if you combine colors, if you layer them, you get a third color. Okay, that sounds simple, but that means a lot. When you look here, this is just a demo that I'm going to build up into the game. So I have timers set. And the timers will display the backgrounds, and then we'll cycle through the different characters that I have, so you can get an idea of what they're going to look like in each of the different backgrounds. I've also set it up so that if you press the joystick, it will show a fireball or a fire attack like what Ryu or Terry Bogard would do in their video games. And so the method I'm using here is and this is a method anyone can use. I use either 2 or 4 screens all the time. So I never just use one screen to show my graphics. The second you begin using 2 screens for your graphics, you're getting 2 instances of the sprite. If you put those 2 sprites over each other, then you will have 3 colors available. You'll have the first color sprite, you'll have the second color of the second sprite, and then wherever the sprites are overlapping, you'll have a third color. The Atari's luminescence, the way it treats the luminance of the color affects this greatly. So, but the drawback is it also affects the overall brightness of the sprite. So you can do this same method with backgrounds. If you have 2 backgrounds that are both single color and layer them, you will now have 3 colors. Wherever one background's sections are one color, then it will be that color. Wherever the second instance of the background will show its little points that you've turned off or on, the on will be that color. But then wherever there are spots that are overlapping, you'll have your third color. So I know how to mix colors. You know, I know the primary colors and secondary colors, and I know that I know that I can mix colors. I know that red and blue can make purple. I know that yellow and blue can make green. You can use this. This was how I made graphics. So if you look at what I've come up with here, this is what will end up being the game. We have the original boat graphics, Ryu and Terry Bogard. These are 3 color sprites. So anywhere where there's gray is one sprite. Anywhere on Ryu, anywhere where there was the skin tone, that's brown. But anywhere where they're combined is a darker color. So you can see he has flesh tone, he has the outline darker color for the belt and for accents, and then he has the lighter color for his gi. This same method is being used for all of the characters, and I've been fine-tuning the graphics so that they're either not too dark or not too bright. And of course testing it on several television sets with several different Ataris. And I fine-tuned and tweaked things to where on several different systems this looks good. It looks good enough to play. You can see the shimmer effect when I do the fireball attack. So in this game, I am constantly updating the screen. Most of the time people will update the screen one time. The command for updating your screen, telling the system, draw all the data that I've fed you, is draw screen. When you type draw screen in, whatever you've jammed into your loop is now going to be spit out onto the screen. I am using 4 draw screens in a consistent, continuous loop. 1 background with rows of color using the super chip's capabilities of having a higher resolution background. This is using 23 rows super chip. You can use more. You can use 32 rows of color. Now, the reason I'm using 23 instead of 32 is because it frees up variables, which I use a lot, but also because it takes up less ROM space. So you want to conserve ROM space. The more backgrounds you have, the more ROM space you're taking up, the less space you're going to have for sprites. And what I want is the whole move set of each of these sprites and good looking backgrounds. So I can't have 10 backgrounds, or I'll only be able to have 1 or 2 characters. And so gradually, as I add the move sets for each of these characters, once I've achieved a complete move set for each character and I know how much ROM space that's going to take up, I can either add or take away backgrounds. And I expect that I will be able to add characters and backgrounds once it's done. A lot of the moves are not going to take up as much space. They might only be small additional sprites that are part of the character. So you can see I don't have fireballs for either the ladies. Now I've been cycling through bad guys in my mind because I realized that these are 4 good guys from the game. And so these would just be good guys all fighting with each other. It made me kind of philosophize about Street Fighter 2 and how it's essentially all good guys. The 8 characters you choose from in the beginning, albeit some chaotic or less neutral than others, are really not bad guys. None of them are really good or bad guys. They're all, of course, they tack on the storyline. Chun-Li is avenging her father. Guile was friends with Blanca, who was an experiment. None of that's true, though. They've warped the story and made it Hollywood to kind of fit in. But in the original story, Blanca was just a child that was lost in the Brazilian jungle, and his anklets gave it away. Like the mother had given him these, expensive, intricate anklets, and that's what's on his ankles. What they warped it into was that he was a genetic experiment gone wrong from Shadow Law or whoever, and he was actually a military friend of Guile. And that's not how the original story was. So in the original story, without Hollywood, manipulating the intellectual property of Capcom or whatever, we end up without any of that manipulation, a plethora of good guys, So, of course, if you know the history of Street Fighter 2, you know that originally the main bad guy, who we call M. Bison or Major Bison from the manipulated story, was actually Vega. His name was Vega. Balrog was the Spaniard with the claw and the face mask, and M. Bison was meant to be a take on Mike Tyson. So M. Bison was M. Tyson, and I guess they, Nintendo already had Mike Tyson. Mike Tyson probably didn't want to be represented as a bad guy boxer. The 4 bosses that ended up being available in the Champion edition of the game were essentially bad guys. So you've got Sagat, Balrog, M. Bison, and Vega are your bad guys in the game. But the 8 playable characters from the beginning aren't bad. You know, they're all, you know, whatever. Zangief might have been kind of thought of as a bad guy, I guess, but not really. He's just a Russian wrestler. He's not a bad guy at all. None of them are bad guys. So I realized that all 4 characters that I picked for my game are all good guys. And so I'm thinking, who am I going to pick to be the bad guys in this game, and how many bad guys can I add? I thought about adding 3 or 4 more characters at the most, 2 more characters at the very least. And I thought that Sagat would be perfect because he's Ryu's nemesis, and maybe 1 more. Now I probably don't want to pick the Spaniard, Balrog or Vega, depending on what version you're playing, because he's so iconic. You know, like these characters are, you know, even though Chun-Li, believe it or not, that's a traditional kind of Chinese dress, so she's less iconic than you might think. She'll be immediately identifiable as Chun-Li, of course, but the most iconic of those would be Vega or Balrog, the Spaniard, because he's got a claw and he's got a face mask and he really looks like, you know, some kind of, I don't know, bad guy. So to pick 2 or 4, of course if I do 4 I can use all the 4 original bad guys, but then I don't have as many good guys in the game. Now as this is cycling, you can see that it doesn't look bad. I don't know how well you can see it on the camera. I've got this camera zoomed. Okay. I'll try to take up the screen. There we go. That's pretty good. You can still see, at least from the distance here, a little bit of ghosting on Ryu. And like I said in the last video, the ghosting is much less apparent, sometimes non-existent, on a CRT television. So the next thing that I've discovered, and this is very, very useful if you want more than one sprite using your Atari. Now, I use Visual Atari Basic. It's a lot faster, and it's very easy to use. I didn't intend this to be a tutorial really or anything like that, but you know, just one of the methods that I use, other than doubling screens to create extra colors, is I'll use the control playfield options. Now when you use the multi-sprite kernel, you want to get more sprites. Well, you do have a lot of kind of problems inherent with that. You either are flickering or blocking out sprites when they overlap on a horizontal plane, but you still have more sprites, so you can have more graphics going on the screen. It's very useful. But one of the drawbacks of your multi-sprite is that you know, your left side of your screen is the same as the right side of your screen. But if you use the control playfield, control PF command here, you can actually stop that from happening. So under normal circumstances, when you use multi-sprite kernel, you're going to get a 16 section wide background. And as you can see, I have 16 dots here. Now this was originally used for a fighting game with Asuka. So yeah, okay, but I'm actually using this to test out some other things. That's why some of the names are from a different game and things like that. It's that's not important. So the 16 sections wide, this isn't pixels, they're squares, will be doubled. So here's a little row I've drawn to create a turn on a street. This is if you suppose you want to make a driving game, and you know, you can use the standard kernel. You can use Superchip standard kernel, have a nice higher resolution background. You can do different turns, use different color patterns and things, but you're still only stuck with, you know, 1 or 2 sprites. Now, if I use my method of drawing, suppose I use my doubling of the sprite method to create a 3-color sprite for the car. That's fine, but I can use that method as well for the oncoming traffic, but it limits me to only 1 car using the standard kernel. If I can have 2 cars if they're only single color. If I only use player 1 colors and use the overlapping technique for player 0, I could have a 3-color player 0 sprite for the car and have row colors for the oncoming traffic, but that still limits me to only 2 cars. I can use the sprite doubling, where the system will generate 2 or 3 of the same sprite, either close, medium, or long distances from each other. But to get the right effects of that, where a car will approach your car and look proper, would be very, very difficult, because you would want to be able to have the car match the curvature of the turn and all of those things. So to use the doubling of sprites to achieve 3 colors with the methods I'm using with multi-sprite would give me roads and up to you know, 6 different sprites, and so you could have lots of oncoming traffic. Perhaps you could have, like with runout, objects that are zooming as you drive past them. So I want all of those things. I want the more sprites, I want the 3-color sprites, I want the turning, of course. Now, when you think of the multi-sprite kernel, though, if you don't use this option that I've used, you're just going to end up with a mirrored playfield. So how do you make turns on a mirrored playfield? You can't. If you draw this curve here that I've got, and I'm just mirroring it, then all I'm ending up with is a straight path. So I'll explain. Here is your control playfield with 1 ticked. I'll go ahead and show you in the instructions what control playfield does. I keep the manual ready at all times in a little internet window. Now my systems, none of my programming systems, none of my game systems are ever online. I don't play online. I don't have any system that I do any crucial or important work on hooked up to the internet. I just won't do it, because whatever could happen with the internet, an update, virus, Trojan horse, malware, whatever, I don't want it ruining my work or my play experience. So none of that's it. So this is actually just the web page, and this came with one of the earlier releases of, I guess they had the forethought to consider that might be a situation with a programmer, and so they just put the manual in HTML form. The later versions of Visual Atari Basic do not come with the manual, and you might have to try to look up the information. But I just keep the manual opened off to the side. Now here's control playfield, and here are your options. You have 0, 1, 2, and 3 for the left side variables. Then you have 1, 3, 5, and 7 for the right side variables. Now on the left side you'll have different widths of your ball, okay? But then on the right side you can do these more intricate, eccentric things. You can have the left half of the playfield have the player 0 color, or the right half have the player 1 color. That's weird. You might find a use for that. I don't. I'm not using that. Players move behind playfield. That's cool. If you want to have them be covered up by whatever the playfield is doing. That might be cool. Like maybe the clouds in Time Pilot you'll go behind the clouds when you fly. So that would be cool. Both of the above, that's each of these, or one, which is none of the below. Now this doesn't say what happens on this list if 0 is put into the control playfield option here. You have 0 up here on the left, which is your normal 1 pixel wide ball, and then increments of the width of the ball for 1, 2, and 3, up to an 8 pixel wide ball. That's great. But here on the right side, there is no 0. But if you put 0 in on control playfield on the right side, I've just put 3 on there for an 8 pixel wide ball. I might not even use a ball. I can put 0 there, it really doesn't matter. Later on, if I decide to add a ball and have it be 1, 2, 4, 8, however many pixels, on multi-sprite kernel, you can't control the height of your ball or your missiles. They're all fixed. So, as much as that might suck, none of these options will matter very much, unless you really want an 8 pixel wide ball for some reason. Maybe. But then the right side options, as eccentric or useless as they might be, if you put 0 on the right side as an option, now your playfield will not be mirrored, it will be doubled. This is how you can make turns in a racing game. This is also how you could vary background objects. So suppose you have a building on your screen, like maybe it's just a picture of a building. Well, if you use normal playfield, then that building will just be mirrored. So you could draw half of a building in the middle of the screen. Then when it's mirrored, the other half will be there and you'll look like you have one building in the middle of the screen. That's really cool. A lot of video games do this. Street Fighter 2 does it. A lot of video games mirror the backgrounds. You might not even know unless you really take a step back and examine it and realize, wait a minute, that's exactly the same on both sides. And if they do that, it saves them space. So this is a safe space, a space saving, and it's also so that they can give, in this particular instance, so they can give you the extra 5 sprites, or actually it's extra 4 sprites on top of player 0 and player 1. You'll get player 2, 3, 4, and 5. So you get 6 sprites total. And you have to be careful how you use them. If they overlap horizontally, they can either cancel each other out or flicker the crap out of each other to where it really doesn't look that great. So if I look at this screen here, I've got control playfield 1 enabled. I'll go ahead and just put 0 here for this one because right now the ball isn't even being used. I've got this to be the color of the sky, and I've got empty rows so the sky color can come through, but I also have rows to generate the street's levels as they're coming towards you. Much like in Outrun or in other racing games that later on I will animate this. These will change so that it appears that you're moving. So that's going to be kind of a fake scaling effect. Now up here I've got the curvature that will become the turn. Now if I go up here to control playfield, again I'll just put 0 in here. Now this says 0 as the second one. We're just going to put 1 as the second one, which will mean none of the below for any of the variables. So it essentially is just saying don't do anything for control playfield. So this would be your standard multi-sprite effect. I'm going to save and compile it, and you can look, and it's just going to be a road. Okay, there we go. Now you've got your sky, you've got your rows, you've got your lines on the sides of the road. This could be if your car is going down a straight path. Now, because this is multi-sprite, I can have pixels have sprites represent the objects in the background moving towards you, also have cars moving towards you. If I'm careful about it, they won't flicker or cancel each other out. And I can have several cars move towards you. That's cool. Now, but then, oh, well, I can only mirror them, so how can I make it turn? Well, that's the thing that I discovered. If you put 0 in the control playfield then the right side is not mirrored, it is doubled. So we're going to do that real quick. Now I'm not doing that with this bottom one. These colors I want to go all the way across the screen. So on the second instance, the second draw screen, I'm actually leaving the playfield at 1. So this will be mirrored. But this first instance, I want this to look like I'm turning right. Like there's a right turn coming up ahead. I don't want it to just look like a straight path. So if it's doubled, it will look that way. If it's mirrored, it looks like a straight path like what you just saw. So here, I'm going to tell it control playfield 0. Now I'm going to save and compile it, and we're going to have a right turn approaching. There we go. So now, because that's doubled instead of mirrored, and I can do that on the left and right side, I can very easily generate the turns of a racing game. Now that, coupled with objects moving from the background, objects fixed in the distance, sprites used as oncoming traffic, all with 3-color sprites, I could have a pretty good looking racing game. Now the problem I run into here is the rows of color have to be the same all the way across the screen. If I get rid of the rows of color, then it's all a solid color driving surface. So there are a couple of problems with it. There are a couple of things to work out to try to get the road to appear different than the sides of the road. If I just get rid of the lines of distance, there's less or nothing to show motion. So so there are ways to work around that, but for the most part, this is where it's at. Now if I add, suppose I want to add more color, like if I added rows to the left side, well I'll just add 1 row to the left side here just to show what will happen, and in case I was going to match it up. And of course what will happen is this row will be doubled, so it will be coming over into the street, into what would be the street in the graphic. See? And I don't want that. I would want it to be on the right side of the screen. So I can't do that. I can't just add a row and then have it be okay like that. So now if I add it into the center, suppose I want to use it to come up with a street, then the right side of the screen where you would have markers is filled in. And if you notice, it's filled in all the way to the very edge of the screen, which kind of doesn't look good. It doesn't look proper. So you can't just add those extra colors there like that. But with this method, you can use the multi-sprite kernel to have non-mirrored backgrounds. So this could be used for a lot of different purposes, not just driving games. You could use this for static backgrounds to add whatever backgrounds you want for any game. If you're creative and careful about it, then this will eliminate that mirrored look on your backgrounds, because it's not mirrored, it's actually just doubled. Some other things I've done, like for 3D, this is the first, let's take a look at that. Again, these were used for a different game. Now here we have wall edges and the mirrored effect. It's kind of hard to see, I haven't tweaked the colors. And of course, this could appear to be coming towards you. Maybe you have a jet that's getting ready to launch, and this is going to be your launch scene. And so you would have this screen move down in increments until it's gone, and then you just, when it's animated, you feel like you just launched. I could also have the rows move towards you, okay, by animating them or color cycling them. So that's kind of a trick you can do. Now, so that control playfield option, I don't know why they didn't put that in the instruction manual, because that'd be some pretty good information for someone that wants to use multi-sprite kernel, but they don't want to be stuck with mirrored backgrounds. Even though mirrored backgrounds can be very cool and useful, and they free up more space, so they don't take up as much of your ROM space. Now, originally in this game, I was using mirrored backgrounds, and so I was going to go ahead and do something like this, where this is the multi-sprite kernel. Maybe not. Oh wait, no, it's this first one, maybe? No? Okay, that's gotcha. It's a different one. So I'll close that project, and it's this one, maybe. Let's try it. Yeah, this is the multi-sprite one. And let's see if this is the right one. Now, yeah, here we have what you can do with multi-sprite. This is just the left side is drawn, and then it's mirrored so that you get this effect where, you know, so I've got the building in the center, I drew half of that, and then when it's mirrored you get the complete building. Okay, and actually there's a better looking one. Let me see if I can find that's build. No, this is right. That's the right one. So we have this. This is the arcade background. This is supposed to be like a subway. This is a quick stop, like it's a convenience store. Now I like how the sprites look in this, but overall there's a shimmer effect that has to be controlled by raising or lowering colors to kind of match up. And you get different effects. You can have all the colors match up on the same row of luminescence, but you'll still get this shimmery, flickery kind of effect. And so you have to tweak the colors until everything agrees, and what you'll end up with, usually, with this method, is a very dark picture. So, to eliminate that darker picture, you know, you have to tweak the colors as much as you can to end up with what you want. Now, it looks good on a screen. It doesn't look bad on a TV, but the images can be relatively dark. This is why you would choose the single color, rows of color, or standard kernel rather than using two single color overlapping backgrounds to get a third color. But if you look at this image, you can see that I have two backgrounds, and where those two colors are combined, I'm getting a third color. So there's one color, maybe the gray, there's a color for the parking area and for the doors, there's a color for the health bars up at the top. We also have, and those are sprites, and then the quick, the sign that says quick, that's actually a sprite. Now because I'm using two instances of the background, that's actually the same sprite, but it's being redrawn and moved in that second instance of the background. Same effect that's being done in a lot of other games, but in this case I'm layering the characters, I'm layering the background, and then I am creating a second instance of and separating a sprite for the quick sign. So on this one I'm doing that with 32 KB on the arcade machine. So they're layered. Where you see the yellow color, the gray color, the blue color, these are all, there's a single color background and then a second single color background, and they're overlapping each other. And that effect is creating the three color sprites for the characters by overlapping the sprites, three color background by overlapping the background. Same here. That's what the method is in this demonstration. And it ends up creating really good looking sprites. But the backgrounds, you really have to be careful with the luminescence of the backgrounds. But it takes up much less ROM space. This is a way to have more sprites, save ROM space to have more animation and more things going on the screen, but also to kind of limit your amount of color for the backgrounds, but possibly have more backgrounds. Of course, they all have to be either mirrored or they have to be doubled using that control playfield method. So what I ended up doing was creating a second instance of the game that, rather than being multi-sprite, is the super chip kernel in standard mode. I'm using no blank lines, so there's no row colors, and I'm using playfield colors. I'm not using player or player one colors because I'm using the layering trick to achieve a 3-colored sprite. So the dock, each of these is a row of color on each one. This is your image. It's 32 sections wide by 23 sections high. And what this does with the super chip is it gives me this many more variables. Your variables would normally cap off around the end of the alphabet here. But then because I'm using 23 rows instead of 32 with the super chip, I get all the way down here to 45 extra usable variables. This is so much more math that can happen and much more control over what's happening on the screen. Here's your constant playfield resolution of 23 that works with the super chip. I'm creating a more accurate randomizer, and I'm having a variable control the score color, the color behind the score itself, so that it matches up better with the screens. And what I've done is I've just made it blanked out to letterbox the screen slightly. This is a timer. This has nothing to do with what the final game will do. This timer is creating a slideshow effect, and then each of the instances of timers will change the characters and the backgrounds so that I can preview each character with each background without touching anything. So I can just sit back and watch it. Now I've also got the joystick fire buttons to show a fireball and an effect from each of the characters that have those. As you can see, here are the 4 instances of draw screen I'm using. The A block, and it goes to each of the backgrounds and to the first instance of each sprite. The second one goes to each of the backgrounds again, but now the second instance of each sprite. This is where the overlapping takes place. Here we're back to the first instance of each sprite and the second instance. Now, in this 4th instance, I'm allowing the joystick to reach out and grab an attack. So I have the Ryu Fireball and the Bogard Fire Wave. Okay, so if I look at this on the screen, now I know this is what it's going to look like when he throws a fireball. And then this is what it's going to look like when he does the fire wave. And this is how it is on DPC Plus, is how it is on anything. When you're combining that many sprites in a horizontal field on the Atari, you're going to get a shimmery, flickery effect. But I'm doing it artificially by having a 4th instance of draw screen, and then instead of a character graphic there, I'm adding a effect graphic. What this does is it makes it so that I essentially have an extra sprite to use, even though this isn't the multi-sprite kernel. So I guess I'm artificially generating a 3rd and 4th sprite using the standard kernel by doing this method. And amazingly enough, it flickers just like it would if it was a multi-sprite kernel sprite. So those you don't want to overlap. And in this case, when they're overlapped, they create the same shimmering or flickering. Now, and sometimes when you overlap on multi-sprite, it will just kick the other sprite right off the screen. So this is better because it's not kicking the sprites off the screen. It's still letting me have those extra effects. So I have to draw all the fighting moves, and then I have to decide if I'm going to do a instance where the same resolution is used, but the characters' sprites are separated slightly to create a wider sprite for the attacks, or if I'm going to use the same width of sprite, but double the resolution to allow for the attacks. And it's not going to look as good. You know, I mean, when you double the pixels, they're all wider and fatter, and you get a chunkier, blockier looking graphic. But if I just move the sprites to make a wider one, the first instance being a little to the left or right, and the second instance being further away, then I'm going to have a loss of color on one or two sides of the character. So maybe Ryu's left foot there would be gray instead of peach colored, but his fist would be sticking out, and that would be peach colored. So it's a compromise. I'm either going to have lower resolution attacks because of the hardware sprite doubling, or I'm going to have lower color sprites for separating the sprites to create the wider sprite for the attack. Now with the original Street Fight World game, I didn't use this method. I used rows of color. The DPC Plus kernel allows you to have player 0 and player 1 colors and have no blank lines on the screen and have like 9 sprites. But that was using the ARM chip on a Harmony card. You know, more modern technology. And I used player rows of colors, so you have a straight line of colors. Now, and they don't look like real sprites. This gave an effect of the one arm of Ryu or Ken being the solid color of their gi, which I didn't like. It gave the effect of separation in between screen updates for the halves of the sprites as they were coalescing. And but it did give me the width I needed for attacks. When you attacked, the width of the sprite was already there because it was a 16 pixel wide sprite instead of an 8 pixel wide one. But in this case, having the 3 colored sprites looking as good as they do might be enough to compensate for the lower resolution of the sprite doubling using the hardware sprite doubling. So I'm going to test out each of those methods and decide which one I like better, and then make a decision which one is going to go into the game. I'm going to try to add more characters. I'm going to add all the moves, and if after adding all the moves and more characters I have more room, then I'm going to add more backgrounds. So just kind of a little update there on how this is working. And I might start making videos about how to program these games in this more eccentric way that I'm doing it. So on the note of doing tutorials for designing Atari games, I do think I would be helpful for a lot of people wanting to design games for the Atari. I'm an eccentric programmer. I've used machine code on Atari 8-bit computers, but not for the Atari itself, the 2600. And I can tell you with utter certainty that if you want to take as long as humanly possible to create a game, by all means use ASM. But if you want to make a game fast, there is nothing wrong. And I would recommend there's nothing wrong with using the Visual Atari Basic, or at least Atari Basic. When you think of creating a game in Basic, people often think of the old world of extraordinary RAM limitations and no direct, it's high level code. So so when you think of high and low, most people immediately associate high with positive and low with negative. But in this particular case, it's the opposite. Your high level code is looming up above the hardware, and it has to interact with some type of interpreter or some type of translator to get the machine to understand it. And in this case, that translator would be the BASIC language. In old computers, BASIC was more limited. With a system like the Atari 8-bit computers, they considered this. So, believe it or not, the Atari 8-bit computers have something called a six-page horizontal sprite mode. And because calculating the location of the sprite is made extremely slow by using BASIC. So when you're coding, and I've actually played some games that were coded in BASIC completely for the Atari 8-bit computer, and they're great games. There's a Burger Time clone that was coded entirely in BASIC, and it is leagues better than most Burger Time clones. It's not that you can't record or you can't create a good game in BASIC even on those older systems. But my point here is that using Visual Atari Basic to make an Atari 2600 game does not limit you. You're not going to be limited. In fact, what is actually happening is, and you can validate this, you can verify this yourself, is your code's being turned into assembly. And you can see it. The tilde key will open your program as it's running, and you can see what your program is in assembly. Now, of course, anyone that is, in love with assembly language is going to look and go, oh God, you could do this and change this and delete this and refine this and move this, and oh, it'd be faster and it'd take up less space and all this stuff. Well, what I learned when I coded in assembly was that assembly is so fast you have to slow it down to even see what the hell is going on the screen. Okay, your stuff will be moving so ridiculously fast that you can't use it. So you just at raw level ASM joystick interaction, suppose you've drawn a sprite on the screen and you've tied your joystick to the sprite, you're going to move the thing around on the screen using assembly. It will be moving so fast you can't use it. Like just tapping the button and that thing's going to go all the way through the screen and back from the other side 10 times in a blur. You have to fill in space to intentionally slow down assembly to even get it to be usable. So if you complain about BASIC being slow or inherently flawed, well, in some cases it is. It's true in the older systems but there are strengths too. If you know tricks and if you have figured out what you're doing, you can do a lot with BASIC. For instance, on the Commodore 64, you can redraw all of the placeholder sprites for the letters and numbers. And then you can put them on the screen using the commands for those letters and numbers in BASIC. So as fast as it would print out typed words, which is very, very fast, you can have an entire screen of graphics using BASIC. Yes, it's slower than ASM, but ASM is so much faster than even a video game that slowing it down is essential. You must slow down assembly, and you might have to do things to speed up BASIC. A trick that they used to speed up BASIC, and a trick one can use on the older systems. This is not Visual Atari Basic I'm talking about, just older systems. And they knew this. They knew that you needed to do stuff like this. But one trick you can do is make your screen larger than what's visible, and on the outside of your screen put all of the graphics you're using. And then within the game, use code that is cutting out a chunk of the graphics that are already loaded on the screen and then putting them in different places on the screen. This is something that BASIC can do very fast. You can do this to make arcade games. You can do this to make any game. So using the hugely slow, rudimentary, initial BASIC, of course, is going to be slower than anything else, and you're going to have a hard time getting anything out of it, and you're not going to make an arcade game. But once you've learned a few tricks here and there, you can make completely approachable, effective, usable arcade style games, even on old systems using BASIC. You should not think BASIC sucks, I won't use it to make a game, because you can make really great games using BASIC. Now, that's in the old world with your Atari 800 with 48K, or your 130 with, however many, 64K or something, 128K. It's old systems. I'm talking about Visual Atari Basic for programming 2600 games. It's a great system for programming Atari 2600 games. You're going to make an Atari 2600 game that's great. That's just like or better than. And in fact, since I've learned all of the ins and outs of Visual Atari Basic, and I've learned how to do things with it, having a game published, and it was a great game, one of the greatest games ever. It's not available anymore, but it's a great game. I look at video games now that were originally made in assembly, and I sit there and think, through my mind, I just run through the process of turning that into a better game using BASIC. And of course, the very first thing I think is creating a second draw screen to add a second layer of graphics. And immediately, every single game that you have for the Atari 2600 would have 3 colored sprites. So imagine if every single Atari game that you've ever played, Joust, Frogger, Donkey Kong, any game, okay, and instead of having rows of color, you have a single color layered upon another second single color that creates a third color. You have 3 colored sprites. So immediately, every single Atari game would be better. Every single one of them. Even if you kept the crappy row of color layered backgrounds, or no backgrounds, or single colored backgrounds, single colored borders, just adding a 3-colored sprite instead of a single colored sprite would make every single Atari game look that much better. And fine-tuning the colors, you would have a great game. All of them would be better immediately. Now, I've noticed that people will hack and adjust colors on and redraw graphics for original Atari games. The best xenophobe is the redrawn Atari 2600 xenophobe. It is so good, and it's fun, and it looks great. The original xenophobe for the Atari was an atrocity. I mean, the only thing worse than it was the Nintendo version of xenophobe, which wasn't even xenophobe. It was like Xenophobe 2 messed up. But someone took xenophobe for the 2600, and it had crappy graphics. Like, it had like blue aliens, and the characters looked terrible. And they redrew the color rows. It was already using color rows, and all they really did was went into assembly and flipped the switches for the rows of color to where the colors were different. They redrew the sprites to make them look more like the arcade, and you end up with a really solid xenophobe. Another popular thing was making them kind of vectorized. Someone made a vector version of Star Trek, a vector version of whatever. And basically they're just going in and making holes in the sprites so that there appears to be rows, drawn out lines and stuff. What it ends up doing though is making a all-around better looking game. So like the Klingon battle cruisers in Star Trek now have holes in the graphics. They have gaps and black spots. It's supposed to be vectors like they're drawn with lines, but because the sprites are so small, it just makes it look more complex. So it's a more complex image, and it just looks better. So there are ways to make it look better, very simply. Now, of course, anyone that's used emulators from the old school, like Nesticle and stuff like that, knows that these emulators will allow you to access the graphics as they're being printed on the screen. And then, of course, you can go in and redraw those graphics if you know what you're doing, and completely redraw video games. And this has been done, and that's how you get a lot of these mods and hacks jobs and stuff for your favorite Nintendo games, where entire games are redrawn, like where they made every character in Castlevania a harpy or a female or a hot-looking, hot chick, good guy, whatever. Those are all redraws. You can do those using emulators. You don't need BASIC, you don't need coding skill, you just need to know how to open that feature in the emulator and redraw it. But when you're using Visual Atari Basic to make a Atari game, then you do have the power to make games that are as good or better than the original games that came out for the Atari. There's no reason why you can't. Now, they thought they were kind of crippling it a little bit, but the truth is they were making a really good standard to create video games. And I've used Visual Atari Basic for over a decade. And when about 7 or 8 years ago, after I had first had Titan Axe published, I realized how I would have done Titan Axe differently. Okay, and so if I do decide to do tutorials, it's not going to be like Random Terrain's tutorial that just explains the functions and here's your crappy video game. It's going to be how to make a game that looks better than any other Atari game you've ever seen. And I use eccentric methods with varied results. But, you know, I know what I'm doing. And so I could totally do tutorials on how to program with Visual Atari Basic. And you'd make video games that are the new wave of Atari games that are better than any 2600 games and better than a lot of Atari 8-bit or even some entry-level 7800 games with these newer types of methods. Now, ideally, I'd love to program 7800, and I have programmed 7800, and I've programmed Sega Genesis. But the low-level code, which is just assembly that is immediately turned into machine language, you're in the high-level code. And so you need to be very careful about how you do things. It's you have to trim things up to where you're getting a good enough effect. You're getting a good enough product to where it's not just sticks and outlines and, you know, crappy backgrounds. And, you know, I'm sorry, I hate to say this, but there's just a plethora of shitty Atari homebrew games. There's an alarm clock, and there are just the most crappy Atari games you've ever seen, where someone just took a single color crap sprite and then, you know. So, okay, when I redo Titan Axe, I've said this in the last video, there's going to be less backgrounds. You know, I did the math, and if you're using like 30 some odd pixel tall characters that are 8 pixels wide, you could draw upwards of 80 sprites or more. You can put that many sprites. So imagine what you could do. Well, imagine what you could do with 96 sprites. Of course, they're not on the screen all at once, but 96 sprites to cycle through to use for your game. And that's if you're not using any background. So you just put a rudimentary crap background up there. That's how many sprites you can have that are varied. And depending on what kernel you're using is how many you can show at once and where on the screen and what effect they'll have. But I've done the math. And you could fit even more if they're smaller. When you use very low resolution backgrounds using rows of color, you might get, you know, they could use up to 128 bytes, you know, out of your, you know, 3 kilobytes or so of ROM space that you're going to be using for your graphics. So there's a balance, and you know, you're not really trapped when you use Visual Atari Basic. You're not trapped in that world of old world of really slow, crappy interpreters that really can't be used. You know, like I was talking about the 6th page horizontal sprite mode, that can be accessed in Atari 8-bit computers in BASIC, and it's meant to accelerate the horizontal movement of your player sprites to allow them to be much like an arcade game. And then your real worry is calculating the vertical location of the sprite. And it's much, much easier to do. It's so much easier when you're using that. And they knew it. They're like, they were thinking before they designed the 800 or the 400, how can we make it so people can use BASIC to make their own arcade games? And so they put that in there. So it's not like they were thinking no one will ever be able to use BASIC to make games. They foresaw people using simple coding languages to make their own games and that being one of the big selling points. And so, and there are a dozen varieties of BASIC that are all curtailed to different modalities. So they have several basics that are meant for speed and for producing arcade style games. There is no reason at all to think that you have to learn or use assembly. And I'll tell you 3 negatives about it. Yes, assembly's faster than anything, but like I said, you have to slow it down to even get it to be usable for video games. So that's one negative. Another negative is get ready to take forever to type that crap out. Machine language takes, assembly to get it into, to compile it into machine language, typing it out and everything. It takes freaking forever. You can do in a couple of months what would take you years to do in assembly using advanced BASIC. It's just how it is. So now I use a kind of rarer BASIC for Sega called BASI EGAZORS. And I've got the Sega SDK now. And it's basically, a drag and drop kind of pixel drawing and placement and all that stuff. What I'm using is lower. It's lower level, and in this case it's positive. It's static. It's just happening on the screen. And so I've made demos and games and stuff, little mini demos of games, some functional, on the Sega Genesis, and using that. So it's not that you can't make good games using those methods. You just have to, do your best. You have to try. So like, okay, I'll open my Sega emulator here. I might use Kega at times. And I was actually in the ROMs, so I'll have to go back to my BASI EGAZORS and my examples. And I'll find something if I can real quick. Nadia, no. Maybe it's in here, yeah. Okay, here we go, this is great. Will it even work? No, I don't have a joystick hooked up. Okay, so I'll go ahead and tell it to use a keyboard real quick. Okay, now I've got the keys set up. Okay, here's a background that I made for a game. And this uses tiles. Every part of this is done with tiles. But I actually have working stuff. Let me see if I can find that real quick. Here we go. Here we go. All right. Here's an animated character. Okay, she's walking on a beach. This works on a Sega Genesis. And this is just testing some of the things you might want to do. It's got the waves, and that's set on a timer that moves the waves back and forth. It's got all kinds of different animations for her walking and moving and stuff. So yeah, it's just, to kind of give an idea of what can be done quickly and easily on the Sega Genesis. I like to do demos and slideshows and you know, put graphics up there. And as I have so many projects on the 2600, I also have a lot of projects that I want to do on the Sega Genesis. I have some projects that are kind of frozen in time on the 7800 until I get a legit software development kit or an emulator that will actually show the real results on an actual 7800. And I made a lot of slideshows. So, and you know, base EGA Zors is very easy to use. Once you figure it out, it's really, really easy. There's no reason to think you can't make a good game on that for the Sega Genesis. Here's a sprite though in Visual Atari Basic. In this case, I'm defining the player's color. I'm using new size to decide if it's wide or not, or what effects, if it's doubled or tripled. This is a reflect bit that will flip the character sprite left or right. It'd be nice if they had one that would flip it upside down or right side up. That could be useful. And your XY coordinates of that sprite. Later on, this will be reached out for outside of the graphics loop. That way, and of course the XY coordinates will be tied to a variable. That variable will be controlled by joystick inputs. So this is just to put it on the screen to see what it looks like, but I'm not going to have, this stuff's not going to be there later. The loop will just reach out and grab these graphics, and then another part of the loop will reach out and grab the variables that are being constantly changed by the joystick. This is Ryu's first instance of colors, and here's his fireball, and here's his second instance of colors. And as you can see, the second color is 3.6, that's a medium red. And then 08 is a gray color. Okay? And so as those two colors are layered, I get a third color. So wherever there's a gap on one, but a filled in spot on the other, you'll get whatever that color is. Wherever there's a spot where both are on, where they're both a 1, then you'll get the third color achieved by combining those two colors. There's her first and second, Chun-Li's first and second, there's Terry Bogard's first and second, and then his little fire wave. And you can see here, that's the result, is that you get 3 colors. Wherever there's the single color, then there's the second instance with a single color, and then wherever they're combined, you get a third color. That can be done with the backgrounds, that can be done with sprites, with anything, with missiles, whatever. The way the Atari draws graphics is different than most systems, maybe every system. It's very unique. So because the luminescence is what you're dealing with, when you layer 2 colors, they combine just like in art class. So if I take blue in one sprite and then layer it with red, then wherever they're overlapping, you're going to get purple. Okay, now one place where I did this effect to the ultra level, okay, a very extreme result that is, and in my opinion, some of the best graphics ever done on an Atari 2600 is with this game here. Okay, now if you look at this game, Ghosts or Bust here, the Ecto-1 car, to get white and red and blue, took a lot of calculating. I had to figure out what to do to get this car. Look at that car. That is white and red and blue. And if anybody's seen the Atari 2600 version of Ghostbusters, the car is a rose of color and it looks like crap. I mean, it works. You know what's going on with it and everything, but that right there actually looks like the Ecto-1. It looks like the car from Ghostbusters. The ghost up there has glowing yellow eyes, a gray outline, and a yellow body. That is a 3-colored sprite. No published, like actual Atari games, use these types of sprites. There might be a couple of homebrews out there that have figured it out, but for the most part, people don't know this method because they haven't, worked it out as much as I have. I've went in there and figured out all the things. Well, how can I do this? That's how both of those sprites down there, Peter and Winston, are drawn. That's how the background is drawn. That's how Slimer is drawn. Each of them is one color. Then in the second instance, it's a second color. And by combining them, you get a third color. So I got three color sprites on the screen and a 3-colored background. And then of course there's the background color, which in this case is that darker blue, and that can be used to come through. It's used for the windows, for the glasses on the tables, and for the sky. So I might be the only person that does this. I might be one of the only people that's figured this out. So yeah, but yeah, how do you get the Ecto-1 to look like that? You got to really, it takes a lot of work. I'm actually combining, these are all the sprites here, that's the main screen. As I get down here into the driving part, I've got the Ecto-1. Here's the left side of the Ecto-1. I believe I'm pretty sure I've mirrored the car as well and spaced it. Yeah, it's been mirrored and spaced. And then there's 2 instances of the car and 2 different colors. So when I take those 2 cars and I combine these 2 colors, 2 and 6 for the second instance, which is most of the body of the car, and then up here I combine 9, 8 with 2, 6, that's how I'm getting all 3 of those colors. So it's a trick. It's a trick with the car. And anyone can do this, but I figured this out. This isn't something where they don't teach you this anywhere. You have to figure out, just like with the playfield doubling or reflecting in the multi-sprite kernel, I had to figure that out. That's not in any instructions. So I might do some tutorial videos in case anyone ever wants to watch them to figure out how to do more eccentric, unique Atari games.